So theorem 1.7 gives us a couple properties of limits. It says let a and c be real numbers, and c is a constant. Well, first one says limit as x approaches a of c equals what? What do you think that would be if c is a constant? It's just going to be c. Let's think about this for a second. C, that's our function, right? So if it's just a constant, let's look at an example. Limit as x approaches 5 of the function 4. Right, so really 4 is our function. Y equals 4, f of x is 4. That's just a horizontal line. So if we have a horizontal line and we're going along that function approaching an x value of 5 from both sides, the y value is still going to be approaching 4. It's always going to be approaching 4. It's constant. It's always the same. So the limit of a constant is just that constant. And then the limit as x approaches a of x is just going to be a. Basically using direct substitution here. Put a in, we get a out. Right, if you look at that graph, y equals x, just that basic line. So as we're approaching an x value of a, the y value has to be a also, because y and x are the same. Right, so if x is approaching a, so is y. Now, a couple properties down here that we'll see are very similar to some properties that we see throughout the year with different things like derivatives and integrals. Here it says if the limit as x approaches a of f of x and limit as x approaches a of g of x both exist, then the following also exists. So this first one, limit as x approaches a of f of x plus g of x, we have the sum of two functions that we're trying to take the limit of. So taking two functions and putting them together sometimes makes a bigger, more complicated function. Well, what we can do is simplify that. Look at each little piece by itself. The property of limits is the limit of the sum is equal to the sum of the limits. So we could look at it this way. The limit as x approaches a of f of x plus the limit as x approaches a of g of x. So we can look at each little part by itself and then add those answers up afterwards. Sometimes that's easier. Sometimes combining the two functions, things might cancel out, and that might make it easier. So it could be either way. Well, that kind of idea with addition works with the other three operations as well. So limit as x approaches a of f of x minus g of x, same as the limit of f of x as x approaches a minus the limit as x approaches a of g of x. Same thing with multiplication and division. So each one of those can be split up. So, like I said, in more complicated problems, splitting it up or looking at each piece individually can make it a little bit more manageable. And then there's one more property here that kind of combines two of the properties we've already looked at. First, we have c times f of x. So that kind of fits this, like the multiplication, right? So first I'm going to write this underneath before I put the final one over here. We can write that as limit as x approaches a of c times the limit as x approaches a of f of x. But what's this first one right here? What's the limit as x approaches a of c? That's just c, right? So we can simplify this as c times the limit as x approaches a of f of x. So basically, we can kind of almost think of it as taking this constant and putting it out in front of the limit. Technically, we went through a couple properties to do that, but that's kind of the basic gist of it. If we have a constant times a function in there, we can take that out. Just find the limit of the function and then multiply it by that constant afterwards.